Okay, so get this. You send us a paper, and it's about this AI, Goedel-Prover. And wow, it's causing a stir in the math world.
It is pretty wild.
We're talking AI that can create mathematical proofs?
Yeah.
Like the kind a computer can verify?
Hmm?
I mean, how cool is that?
It's pretty remarkable.
It's like having a robot Einstein, but like one that shows all of its work.
Yeah, when you think about it, we're basically teaching AI to think like a mathematician,
Right.
to reason logically and come up with rigorous proofs.
Yeah, but here's the thing that like blew my mind.
Okay.
You need tons of data to train AI, right?
Yeah, tons of it.
But finding all of those complex math problems and their step-by-step proofs and all of that written in computer speak, that's like,
That's the tricky part.
yeah, that's like finding a talking unicorn.
That is a great analogy. You're right.
Right.
That scarcity of data has been a huge roadblock in this field for a while now.
So how did the creators of Gödel-Prover even manage to pull this off? Did
Right.
they round up a herd of talking unicorns?
Not quite.
Right.
But what they did is almost as magical.
Okay.
They tackled the data shortage head on.
Right.
Instead of just settling for the limited data,
Right.
they figured out a way to make more.
Wait, hold on. Did they like hire 1,000 mathematicians to translate these problems into computer code?
Yeah,
No.
because that sounds
That would be a lot.
really expensive
Yeah.
and time-consuming.
Very impractical.
Yeah.
What they did was even more ingenious.
Okay.
They used AI to do the translating.
Whoa. AI translating math for another AI?
Yep.
That's a serious mind-blown moment right there.
Pretty neat trick, isn't it?
Yeah.
They used two separate AIs called formalizers to translate almost 1 million human-readable math problems
Wow.
into this very specific computer language called Lean 4.
Okay.
It's kind of like having two different translators working on the same book.
Right.
They might use slightly different words or phrasing, but the overall meaning is the same.
Got it. Okay, so they have these AI translators churning out computer-ready math problems.
But how do you even begin to teach an AI to do proofs? Will
I
there be
think-
like an AI boot camp or something?
You're actually not far off.
Okay.
They use a method called expert iteration, which is basically like a training montage for AI.
right.
They give the AI a bunch of problems, see which ones it gets right,
Uh-huh.
and then use those successful solutions to train an even better version.
So it's like leveling up in a video game.
Exactly.
Okay.
The AI learns from its wins and gets stronger each time.
And they just keep doing that over and over.
Yeah, and they repeated this process 8 times,
Wow.
building on the previous successes each time.
So 8 times through AI boot camp.
It's a constant cycle of improvement.
Okay, I'm on the edge of my seat.
Right.
Did all of this training turn Gödel-Prover into some kind of mathematical ninja?
But it's definitely showing some impressive skills. In a benchmark test called Mini F2F,
All right.
Goedel-Prover actually beat the previous best AI by a significant margin.
Okay.
We're talking 7.6%,
Which doesn't sound like a lot.
which
but
might not sound like a lot.
I'm guessing in the world of super precise math, that's kind of a big deal.
Yeah, in the world of super precise math, that's a huge deal.
It's like shaving a full second off of a world record sprint.
Exactly.
Yeah.
A major leap forward.
Okay.
But they didn't stop there.
Oh, no.
They also gave Goedel-Prover a set of super challenging problems from the Putnam mathematical competition.
Hold on. The Putnam.
Yep.
Isn't that like the Olympics of college math?
It is.
I've heard stories about how tough those problems are, like even for humans.
They're notoriously difficult.
Yeah.
But Goedel-Prover managed to crack 7 of them,
Really?
which is a pretty big deal considering how much this type of AI has struggled with these problems in the past.
Wow. Okay, now that's impressive.
Yeah.
So this AI is crushing benchmark tests and solving problems that give humans headaches. Is this a sign that AI is about to replace mathematicians altogether?
That's a question a lot of people are asking. But I think it's a bit premature to sound the alarm just yet.
Okay, so breeze easy mathematicians, your jobs are safe for now.
For now, at least.
For now.
What's really interesting is not that Goedel-Prover can solve these problems,
Right.
but how it goes about doing it.
Okay.
And that's where things get a little more complex.
Ooh, I love when things get complex.
Right.
This is where we put on our detective hats and dig deeper, right?
Precisely.
Oh.
There are some fascinating questions about the methods Goedel-Prover uses
Uh-huh.
and whether it truly understands the math. Remember when you asked about AI boot camp?
Yeah, the expert iteration thing.
Well, it turns out Goedel-Prover relies quite heavily on some pre-built tools within the Lean 4 language.
Okay.
It's sort of like having a toolbox full of ready-made solutions for common mathematical tasks.
So instead of figuring out each step of a proof from scratch, it's using these like prepackaged tools to skip ahead?
Right.
Is that a problem?
It's not necessarily a problem,
Okay.
but it does raise some interesting questions. Is it truly innovative problem solving?
Mm.
Or is it just clever use of shortcuts?
Yeah, it's like the difference between baking a cake from scratch and using a box mix.
That's a perfect analogy.
Right. You might get a tasty cake either way,
Uh-huh.
but the process and the level of understanding are pretty different.
Right, and it's something mathematicians are actively debating.
Yeah.
Does relying on these pre-built tools limit Goedel-Prover's ability to come up with truly novel solutions?
Right.
Or is it just a different, more efficient approach?
Yeah, it makes you wonder if relying on those shortcuts could lead the AI down the wrong path sometimes.
Yeah.
Like, following a recipe blindly without understanding why the ingredients work together.
That's a valid concern. It's like the difference between knowing how to apply a formula and truly understanding the underlying concepts.
Right, okay. So this AI is using shortcuts, but it's still achieving some pretty impressive results.
It is.
What else can you tell me about how they trained Goedel-Prover?
Oh.
Did they just throw any old math problem at it?
Actually, they were quite strategic about the training process.
Okay.
Remember how we talked about those two AI formalizers that translated problems?
Yeah, the ones that were like two different translators working on the same book.
Well, it turns out that having two formalizers was a deliberate choice to make the training data more diverse
Okay.
by having two slightly different versions of the same problem.
Uh-huh.
They helped Goedel-Prover learn to generalize better.
So it's like exposing the AI to different dialects of math language.
Exactly.
Okay.
So it doesn't get thrown off by minor variations in how problems are phrased.
Right, like learning to recognize a cat, whether it's a fluffy Persian or a sleek Siamese.
Exactly.
Okay.
The more variety you see, the better you become at identifying the core features.
Makes sense. Okay, so two formalizers, tons of data, a rigorous AI boot camp.
Uh-huh.
What else did they do to make sure Goedel-Prover was ready for prime time?
They also got clever with their evaluation process. They didn't just test it on those standard benchmark problems. They wanted to see how it performed on a data set called ProofNet.
ProofNet.
Yeah.
Okay, so we're going from the SATs to the GREs here.
Right.
What makes ProofNet so much harder?
Think of ProofNet as a collection of college-level math problems,
Okay.
covering topics like linear algebra topology and abstract algebra.
So it's a real step up from the high school level stuff.
A real step up.
Yeah. Okay, so they're really putting Goedel-Prover through its paces.
They are.
How did it handle this challenge? Did it pass with flying colors?
This is where it gets interesting.
Oh.
It didn't do nearly as well on ProofNet as it did on those earlier benchmarks.
Really?
In fact, there wasn't much correlation between its performance on the two data sets.
So it aced the high school stuff but struggled with the college level math.
It did.
That seems kind of odd.
It is a bit counterintuitive,
Yeah.
but it actually highlights an important point about the data used to train these AIs. ProofNet relies heavily on this massive library of pre-proven theorems and definitions called MathLib4.
MathLib4.
Yeah, like having a super comprehensive cheat sheet for advanced math.
Okay, so ProofNet is kind of like an open book exam where you can use your notes.
Right.
Whereas those earlier benchmarks were more like closed book tests where you have to rely solely on your own knowledge.
Exactly.
And Goedel-Prover was trained on a data set that didn't include MathLib4.
That's right.
It's like asking someone to write a research paper without giving them access to any academic journals.
That's a good way to put it.
Yeah, so it wasn't that the AI wasn't capable of doing college-level math.
Yeah.
It just didn't have access to the same resources that the ProofNet problems assumed you'd have.
Right.
Like being dropped in a foreign country and expected to speak the language fluently without ever having taken a lesson.
Precisely, and that highlights a key challenge in AI research.
Okay.
The training data needs to be as close as possible to the real-world tasks we're asking the AI to perform.
Right.
If you want an AI that can do college-level math, you need to train it on data that includes college-level math concepts and tools.
So the researchers basically realized they needed to expand Goedel-Prover's math vocabulary before it could tackle those tougher problems.
Exactly. They've already started incorporating MathLib4 into the training process.
Yeah.
And they're seeing some promising results.
That's great to hear. It sounds like Goedel-Prover has a lot of potential, even if it's not quite ready to replace human mathematicians just yet.
Exactly. It's a powerful tool, but it still has room to grow.
Okay.
And the researchers are constantly working to improve its capabilities.
Okay, so Goedel-Prover is not a mathematical god yet.
Not yet.
But what about the bigger picture? How do these developments in AI change the game for mathematicians? Is this the beginning of the end for human mathematicians?
I don't think it's the end, but it's definitely a sign that the field is evolving.
Okay.
AI tools like Goedel-Prover have the potential to revolutionize how we do mathematics.
So instead of being replaced by robots, maybe mathematicians will become more like cyborgs,
Yeah.
working alongside AI to achieve new heights of mathematical understanding.
I think that's a great way to put it.
Yeah.
Instead of feeling AI, we should embrace the potential it has to augment our own abilities.
Right.
Imagine a world where mathematicians can delegate the tedious, time-consuming aspects of proof checking to an AI assistant, freeing them up to focus on the more creative and conceptual aspects of problem solving.
Yeah, that sounds amazing. It would be like having an AI research assistant
Right.
who can handle all the grunt work while you focus on the big ideas.
Exactly. It's about leveraging the strengths of both humans and AI
Right.
to achieve things that neither could do alone.
Okay, I'm sold on the idea of human-AI collaboration in mathematics.
Good.
But I have to admit, I'm still a bit fuzzy on how Goedel-Prover actually works in practice.
Sure.
Can you give me a concrete example?
Sure. So let's take a simple example from number theory. Imagine you're trying to prove that the sum of two even numbers is always even.
Okay, that seems pretty straightforward. How would Goedel-Prover tackle that?
First, it would need to understand what an even number is.
Right.
In the Lean 4 language, that might be defined as a natural number n is even if there exists another natural number k such that n equals 2 times k.
Okay, so it's basically saying that an even number is any number you can divide by 2 without getting a remainder.
Right.
Got it. What's next?
Then Goedel-Prover would need to formalize the statement we're trying to prove.
Okay.
So something like, for all even numbers m and n, the sum m plus n is even.
Got it. So it's laying down the ground rules in a way the computer can understand.
Exactly. From there, it uses its knowledge of Lean 4 along with a library of pre-proven theorems to construct a proof.
Okay.
In this case, it might start by assuming that m and n are even.
Okay.
This means there exist natural numbers j and k such that m to j and n to k.
Got it. So it's plugging in the variables.
It is.
What?
Then it would add m and n together, which gives us m plus n equals 2j plus 2k.
Uh-huh.
And using the distributive property, you can rewrite this as m plus n equals 2j plus k.
Ah, I see where this is going. So it's showing that the sum of m and n can also be expressed as 2 multiplied by another natural number.
Yes.
Which means the sum must be even.
Exactly. It's using a combination of logical reasoning, algebraic manipulation, and its knowledge of pre-proven theorems to arrive at that conclusion.
That's pretty impressive, but this is a very simple example.
Right.
Can Goedel-Prover handle more complex problems? Stuff that would make even a seasoned mathematician sweat a little.
Absolutely. This was just to illustrate the basic process.
Right.
Goedel-Prover can tackle much more intricate problems involving advanced concepts and longer chains of reasoning.
That's mind-blowing.
Yeah.
But even with all this power, I imagine there are still limits to what this AI can do.
Of course.
Are there any types of math problems that Goedel-Prover just can't handle?
That's a great question.
Yeah.
Like all AI, Goedel-Prover does have limitations.
Okay.
It excels at problems that can be clearly expressed in the formal language of Lean 4.
Uh-huh.
And that fit within the specific reasoning techniques it's been trained on.
So it's not like we can just throw any random math puzzle at it and expect a solution.
Right.
It's still bound by the rules of the game, so to speak.
Exactly. For example, problems that require a lot of intuition, visual thinking, or understanding of real-world contexts might be more challenging for a Goedel-Prover.
It's like the difference between solving an equation and figuring out how to build a bridge.
Uh-huh.
The bridge involves a lot more than just abstract numbers.
That's a great analogy. It highlights the fact that AI still has a ways to go
Right.
before it can truly replicate the full range of human mathematical abilities.
So it's not a magic bullet,
Right.
but it's still a pretty amazing tool that can push the boundaries of what's possible in mathematics.
Absolutely. And it's constantly evolving. Who knows what it will be capable of in a few years.
Now, that's what I call really interesting. But before we get too carried away with all the cool things Goedel-Prover can do,
Okay.
there's another side of this story that we need to explore. We've talked about the technical stuff, but what about the philosophical implications?
Yes, that's where things get even deeper.
Right. If an AI can prove mathematical theorems, what does that tell us about the nature of understanding?
Right.
Is a Goedel-Prover really thinking about these problems, or is it just a very sophisticated calculator?
That's a question philosophers have been grappling with for centuries.
Yeah.
And AI is just making it even more relevant.
Right. I mean, is the AI experiencing those aha moments that mathematicians live for?
Yeah.
Or is it just blindly following a set of rules?
It's a tough one to answer definitively.
Yeah.
Some argue that if an AI can generate a valid proof,
Uh-huh.
it must be understanding the math on some level.
Okay.
After all, it's not just regurgitating information.
Right.
It's applying logical rules to generate new knowledge.
So it's not just repeating what it's learned, it's actually creating something new.
It is.
That sounds pretty thinky to me.
I agree. It's certainly a sign of intelligence.
Yeah.
But there are others who argue that true understanding involves more than just symbol manipulation.
Okay.
It requires having a conceptual grasp of the ideas, being able to connect those ideas to other concepts, and being able to explain them to others in a meaningful way.
So it's not just about getting the right answer. It's about being able to explain why it's the right answer.
Yes.
And understanding how it fits into the bigger picture.
Exactly. And that's where current AI systems,
Right.
even ones as impressive as Goedel-Prover, still fall short.
It's like the difference between knowing how to play a piece of music on the piano and truly understanding the emotions and ideas the composer was trying to convey.
That's a fantastic analogy.
Yeah.
It highlights the nuances of human understanding that are still very difficult to replicate in machines.
So while Goedel-Prover is a groundbreaking achievement, it's not necessarily a sign that AI has surpassed human intelligence.
Not necessarily.
It's more like a powerful tool
It is.
that can help us explore the world of mathematics in new and exciting ways.
Absolutely. And the researchers are constantly working to improve its capabilities.
Speaking of pushing boundaries, you mentioned earlier the potential for human-AI collaboration in mathematics.
Yes.
What would that actually look like in practice?
Well,
I'm picturing a mathematician and an AI huddled over a whiteboard arguing about theorems.
that's a pretty cool image.
Yeah.
In reality, it might be a bit less dramatic than that.
Okay.
But the basic idea is that mathematicians and AI could work together as a team,
Yeah.
each bringing their unique strengths to the table.
So instead of fearing AI as replacement, we should see it as a powerful ally, a partner in exploration.
Exactly. Imagine a team of mathematicians working on a particularly challenging problem.
Okay.
They could use Goedel-Prover to help them explore different approaches, verify their calculations,
Right.
and even suggest new lines of attack that they might not have considered on their own.
It's like having a brainstorming buddy who also happens to be a mathematical genius.
That's a great way to put it. The AI could help the mathematicians see the problem from a different angle,
Right.
and the mathematicians could provide the intuition and creativity to guide the AI search.
It sounds like a beautiful partnership.
It does.
But are there any potential downsides to this kind of close collaboration? Could mathematicians become overly reliant on AI,
Yes.
losing some of their own problem-solving skills in the process?
That's a valid concern.
Right.
It's crucial to make sure that AI tools like Goedel-Prover are used to enhance human abilities, not replace them.
Right.
We don't want mathematicians to become passive observers, blindly accepting whatever the AI tells them.
So it's all about finding the right balance, using AI as a tool to augment our own abilities without becoming completely dependent on it.
Exactly. It's about maintaining our own critical thinking skills, our ability to question assumptions, and our willingness to challenge the AI's conclusions.
Right.
We need to stay engaged and in control.
It's like using a GPS to navigate, but still knowing how to read a map and make your own decisions about the best route to take.
A perfect analogy. It's about staying in the driver's seat,
Right.
using AI as a powerful tool, but ultimately making our own choices.
This has been a wild ride. We've covered so much ground,
We have.
from the technical details of how Goedel-Prover works
Right.
to the philosophical questions about what it means to understand mathematics.
It's been a fascinating exploration, and I think it really highlights the transformative potential of AI,
Yeah.
not just in mathematics, but in countless other fields as well.
Speaking of transformative potential, what's next for Goedel-Prover? Where do you see this technology heading in the future?
I think we'll see continued efforts to make Goedel-Prover even more powerful and versatile.
Okay.
Imagine an AI that can tackle an even wider range of mathematical problems,
Yeah.
from abstract theorems to real-world applications in physics, engineering, and economics.
So it's not just about proving theorems in isolation. It's about connecting those theorems to real-world challenges.
Yes.
And finding solutions that can actually make a difference.
Exactly. And I think we'll also see more research into making these tools more accessible to a wider audience.
Okay.
Right now, you need a fair bit of technical expertise to work with Goedel-Prover.
Right.
But imagine a future where anyone, even someone without a PhD in computer science, could use these tools to explore mathematical concepts and test their own ideas.
That would be amazing.
It would.
It would truly democratize access to advanced mathematical tools.
It would.
Kind of like how calculators made complex calculations accessible to everyone.
That's a great comparison. And who knows, maybe one day we'll have AI math tutors that can personalize instruction and guide students toward the deeper understanding of mathematical concepts.
Now, that's a future I can get behind, but I also hope we don't lose sight of the beauty and elegance of mathematics itself.
I agree.
In all this excitement about AI.
I completely agree. Mathematics is more than just a set of rules and formulas.
Right.
It's a way of thinking, a way of seeing the world.
It's about finding patterns, making connections, and pushing the boundaries of human understanding.
Precisely. And I think AI can actually help us appreciate those aspects of mathematics even more.
Okay.
By taking over some of the tedious work, AI can free us up to focus on the more creative and inspiring aspects of the field.
I like that perspective. It's not about replacing human mathematicians, it's about giving them superpowers.
Exactly. It's about empowering mathematicians to reach new heights of understanding.
Right.
And to unlock the secrets of the mathematical universe.
You know, it's funny, we started this deep dive talking about an AI that can solve these super tough math problems.
Yeah.
And now we're talking about AI math tutors for everyone.
We are.
That's quite a leap.
It is, but it speaks to the incredible potential of this technology.
Right.
We're really just scratching the surface of what's possible when we combine AI with human ingenuity.
I'm curious, though, if AI gets this good at math.
Yeah.
Will humans even need to learn it anymore? I mean, why bother struggling with calculus if an AI can just do it for you?
That's a question that comes up a lot, not just in math, but with all sorts of AI advancements. But I think it misses the point of learning.
Okay.
Math isn't just about finding the right answer.
Right.
It's about developing critical thinking skills, learning to reason logically, and training your mind to see patterns and solve problems.
So even if an AI can crunch the numbers faster, we still need to understand the why behind the math.
Absolutely. It's like knowing how to use a map versus just blindly following GPS directions.
Right.
You might get to your destination either way, but understanding the map gives you a much deeper understanding of your surroundings.
And that deeper understanding is what allows you to adapt to new situations.
Right.
Find alternative routes, and maybe even discover new places.
Exactly the same applies to math.
Okay.
Learning math helps you develop mental frameworks and problem-solving strategies that you can apply in all sorts of situations,
Right.
even ones that AI might not be able to handle.
So instead of making math obsolete, AI could actually make it more important. Yeah.
By freeing us up to focus on the higher level thinking and problem-solving skills that will be even more valuable in a world increasingly shaped by AI.
That's a great way to put it. It's about moving beyond rote memorization and procedural knowledge and towards deeper conceptual understanding and creative problem solving.
Okay, so AI isn't going to replace mathematicians or make math class disappear,
Right.
but it's definitely shaking things up.
It is.
Do you think this will change how math is taught?
I think it has to. As AI tools become more powerful and accessible, we need to rethink how we prepare students for a world where these tools are commonplace.
Okay.
We need to focus less on teaching students how to calculate and more on teaching them how to think mathematically.
So instead of drilling times tables and memorizing formulas, we should be encouraging students to explore mathematical concepts,
Yeah.
experiment with different approaches, and maybe even use AI tools to help them visualize and understand complex ideas.
Exactly. It's about making math more engaging, relevant, and empowering for students.
And who knows, maybe this new generation of students growing up with AI as a learning partner will make breakthroughs that we can't even imagine today.
And that's a thought-provoking idea. It's like we're handing them a whole new set of mathematical tools and saying, go explore, see what you can discover.
I love that analogy. It's about fostering a sense of curiosity, creativity, and a love of exploration in mathematics.
This has been an incredible deep dive.
It has.
We started with a research paper about a groundbreaking AI and ended up talking about the future of math education,
Wow.
the nature of understanding, and the incredible potential of human-AI collaboration.
That's right.
My brain is buzzing with new ideas.
Mine too. It's been a truly engaging conversation. And I think it highlights just how rapidly the field of AI is advancing.
Yeah.
And how profoundly it's going to shape our world.
And for you, dear listener, if you're feeling even a fraction as excited about this as we are, I encourage you to check out the links in the show notes.
You got it.
You'll find the original research paper on Goedel-Prover, some of the Putnam problems it cracked, and even a few examples of the proofs it generated. Maybe you'll be inspired to delve into the world of AI and mathematics yourself.
That would be great.
Maybe you'll even make a groundbreaking discovery of your own. Until next time, happy exploring.